Well, hello there. It's Professor Dan with our next installment of Professor Dan Does Propositional Logic. Videos designed to make propositional logic just a little less heartbreakingly, disastrously annoying for you as we try to finish the semester out. Today, I'm going to talk about the truth values of proposition. That is, how we figure out a proposition if we happen to be so fortunate as to know the truth values of the individual simple propositions that make up even the most complicated propositions. In order to do that, though, we have to know two things. One, we have to know the truth values of the operators in general, and two, we have to be able to find the main operator of whatever the particular proposition happens to be. So let's start with the truth value of operators. There were 5 operators, you may recall. The first 3 that we'll do are negation, conjunction, and disjunction. Because I have only this small little whiteboard to work with, which makes me sad, as I'm sure you can imagine. A negation, we go with a letter. Let me think of a letter off the top of my head. How about A? A negation is not whatever A is. A can be either true or false. Those are the 2 things that A can be. The negation, then, is simply the opposite. If A is true, then not A is false, and if A is false, then not A is true. Simple enough? Of course. But what if there were 2 letters? Let's say we have an A, and we also have D. Ha-ha, you thought I was going to say B, but I tricked you. If I have A and D, well, A can be true or false, and D can be true or false. And the combination of A and D can be different depending on if both A and D are true, or if A is true and D is false, or A is false and D is true, or they're both false. So we need some way to figure this out. And the way we do that is we say, okay, for our first letter, we'll do half true and half false. And for our second letter, we'll alternate true, false, because we have 2 letters, and once we get to singles, then we're done. This is something fun to keep in mind for our next video on truth tables. So if A is true and D is true, then A and D is true. But if A is true and D is false, then A and D is false. And if A is false and D is true, then A and D is false. And if they're both false, then it is false. A conjunction, then, is only true if both sides are true. Same goes with our disjunction. If I have my two letters again, and I have A or D, then again, if they're both true, then it's true. But if only one side is true, if either A is true and D is false, or A is false and D is true, it's still true. A disjunction is only false if both sides are false. So a disjunction and a conjunction are the opposite of each other. A conjunction is only true if both sides are true, and a disjunction is only false if both sides are false. It's so sad having to erase the board like that. But it's a video, you can rewind. Or you can look at the snazzy PowerPoints that cover the same material. What about my other 2 operators? A conditional and a biconditional. If I have if A then D, and then I'll just go ahead and get this out here. A if and only if D, again, following the same convention, half true, half false, and then alternating. If both sides are true, then the conditional is true. If the antecedent is true and the consequent is false, then the conditional is false. But here's where it gets real fun. If the antecedent of a conditional is false, then the conditional is true, whether the consequent is true or false. Let me say that again for those of you looking up from the other tab you were looking at while you were pretending to watch this video. If the antecedent of a conditional is false, that conditional is true. Now you may be thinking to yourself, well, Professor Dan, that doesn't make any sense. Let me help you out with a really easy way for this to make sense. Are you ready? If the antecedent of a conditional is false, the conditional is true. Learn it. Learn it. Thank you. Now, what about the biconditional? Well, a biconditional is true when both sides of the biconditional are the same. Remember, a biconditional is really two conditionals joined by a conjunction. So if they're both the same, then they end up being true, and if they're different, then they end up being false. So that's how the operators go. Well, what if I'm given a proposition? Let's say I'm given the following proposition. And my proposition is going to have 4 letters in it. A, B, and X, and Y. And I'm going to say over here that A and B are true and X and Y are false. And I'm going to make the following claim. I think that blue was my parentheses color, right? That A and B, then X or Y. That's the claim that I'm making. I don't know what A and B actually mean or represent. I'm just told that they're true. Same with X and Y. I don't know anything about X and Y. I've just been told that they're false. So what I can do then is I can replace these letters with the truth values. And then everything else, I just keep the same, being very careful to copy things down the way they are so I don't make a copy mistake and get the problem wrong and then sad because I was lazy at copying. Now, I have my truth values. So I have to figure out which of these things should I do first and which should I do last. And the last operator that I want to solve is what's called the main operator. So I'm going to go ahead and circle that. That's the main operator. Governs the entire proposition. In this case, I have a conditional whose antecedent is a conjunction and whose consequent is a disjunction. So I'm going to solve what's inside the parentheses first. I have a conjunction, both sides are true, and since I'm solving the operator, I'm going to switch to green. And I have a disjunction, both of whose sides are false, so this is going to be false. Now, once I'm down to one letter, I don't need the parentheses anymore, so I let them drop out, but I keep my main operator here. And now that I'm down to my main operator, I can solve that, and as I just learned, a conditional whose antecedent is true and whose consequent is false, And then what I might do is I might circle that if I was writing it down, but since you'll be typing stuff, whatever is the last line of your solution is what we're going to call the final truth value. See, once I knew the individual truth values, I could solve the proposition. It doesn't matter how complicated the proposition might be. Consider, what if I had this? Let's see, what was red was the bracket color, right? And I'm going to put a knot here, and I'm going to say, let's say, Y, B, but to make it more extra fun, let's put some parentheses here, and let's negate the Y, and we'll make this a biconditional, and we'll say, or not. Another set of parentheses here, and we'll say A, X, and we'll make this a conjunction. And now we'll close our bracket. So now I have, it is not the case that either not Y if and only if B, or not A and X. So how do I solve this? Well, the first thing that I'm going to do, just like I did last time, is I am going to sub in my truth values for the letters in question. I'm working with all these different colors for those of you who are visual learners. And where Y was, I'm going to put a false, and where B was, I'm going to put a true, and where A was, I put a true, and where X was, I put a false. So now, everything I checked just to make sure I got everything is the same, but I put my truth values in. It's very important when you do these not to think you can just skip to the end and hope that you get it right, because of course the last letter, the last truth value is going to be either true or false. But if you don't show your work, you will not get all the credit. So there you go. Now, I have brackets, I have parentheses, I've got negations, so what do? Well, I solve things inside parentheses first, but in this case, I have a negation of a single thing inside a parenthesis. So, I am going to solve that first. I am going to solve that first because that's what is the innermost sort of thing. Now I might, if I were just doing this myself, also have solved this inside this parentheses already too, but I want to go one step at a time for illustrative purposes. Now that I've solved that internal, I almost forgot my negation on the outside, because it got me in trouble. Now that I've solved that internal negation, I'm going to do what's inside these parentheses, right? So again, I'm keeping my brackets. My bracket drawing is probably not what my art colleagues would hope it is, but they'll be fine. So true if and only if true, it's a biconditional, both sides are the same. So it's true. And now I have a conjunction where one side is false, and so therefore it is false. My parentheses have now disappeared. But notice, this negation negates this whole thing inside the parentheses. So I haven't solved that negation yet. I have not solved that negation yet. I'm not going to do it until after this step. It's important that you don't do that, because then otherwise you would end up with the wrong thing here, and that could be problematic. So now I'm going to do that individual negation. And I have not true or true. Now if I want, I could be moving these brackets in. Now I can solve what's inside the brackets, true or true. And I know that that is going to be true, but I still have this negation on the outside. Notice how that hasn't been solved yet, right? Why? Because that's the main operator. Because it's outside of the brackets. The main operator can never be inside brackets or parentheses. Very important to remember. A lot of people get confused and they think, well, that can't be the main operator, it's just a negation. It must be this thing here. No, 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 no. This thing right here. That's the last thing that's left. So I can remove these brackets, and now I have not t, which is false, and you see the whole thing is false. So if I know the truth values of the propositions, I can get the truth value of the whole complicated thing. In our next video, we'll see how we can figure stuff out if we don't know the truth values of things. So something for you to look forward to.